Okay, so hello and welcome to yet another closing ceremony of our Inspire Hackathon. Today, after 2 months of hacking, we'll be wrapping up the Agrihub Inspire Hackathon, and we'll have the honor of introducing you to the winning teams that were selected by our jury. My name is Hanna Kubíčková. I'm going to be your host today. And just to briefly introduce myself, I work for Plan for All Association, and I'm mainly responsible for organizing the Inspire Hackathons. This Inspire Hackathon is already the 20th Inspire Hackathon organized by the Plan for All Association, and already the 7th one that is organized fully virtually. Another fun fact is that this hackathon is the second one that takes place within the Agrihub CZ and SK project funded by Smart Agrihubs. The main idea of this 12-month project is to integrate the activities of existing innovation hubs in the Czech Republic and Slovakia, namely Agrihub CZ and Agrihub SK, and to support the interaction of farmers, advisors, machinery manufacturers, developers, or researchers in order to move Czech and Slovak agriculture towards smart farming. A total of 8 organizations have joined together to support the establishment of digital innovation hubs for Czechia and Slovakia and to support the idea. As I mentioned, the idea is also fully supported by Smart Agrihubs, and at this point, I would like to welcome George Beers from Wageningen University and Research, who is the coordinator of the Smart Agrihubs project and who will tell us more about the Smart Agrihubs and its mission. So, George, the floor is yours.
Okay, thank you, Hannah, and good afternoon, everybody. Yeah, thanks for giving me the opportunity to give some, let's say, broader context of this great event that you are organizing today. Maybe good to know that Smart Agrihubs is a project, a 4-year project that is set up for stimulating and boosting, as it is called officially, digitalization in agriculture. In a sense, so basically it is about dissemination of knowledge, expertise, tools, and solutions that are available and collected by a relatively small community at the European level. And the challenge of Smart Agrihubs is to bring it to the local level, to the regions where the action takes place, so to say. And not only in a few countries, but explicitly we are targeting a pan-European approach. So we are present in all member states of Europe and a couple of associated countries also. The concept of a digital innovation hub, as we implemented it for agriculture, is that it is local. It's a local center of excellence, a local center of expertise on digitalization in agriculture. So it's focusing on digital and agri. Very important that this digital innovation hub is embedded in an agricultural community. So it is in the proximity of the farmers, so to say. So it's embedded in the agricultural community. And each of these digital innovation hubs has, we call it a multi-actor approach. So it's, in fact, the Digital Innovation Hub is a network of companies and associations that work together and that complement each other. So it's on agriculture, but it's also on the supplying industry. It's on the cooperatives. It's on the, let's say, the IT, so software, hardware, networks. All those parties are connected to this digital innovation hubs. And crucial is that these digital innovation hubs are connected. They are connected to each other, so they can learn from each other, they can take stuff from each other, but they are also connected to the European network that is working in the Horizon programs. I think Agrihub Czech or Slovakia is an excellent example of how a digital innovation hub should operate. And it's maybe good to say that currently we have connected 327 digital innovation all over Europe. And well, not to please you, but I can say that Agrihub, Czechoslovakia is in the top 20 of the most active digital innovation hubs, definitely. It's a good example that we promote to the other digital innovation hubs as a good example how a digital innovation hub can operate. And of course, I'm happy to facilitate these hubs. Facilitating digital innovation hubs has the main objective to activate them, to make them active, to facilitate them, to do something with their community. There are different types of activities on that, and one of them is the hackathon. So we promote and facilitate and stimulate digital innovation hubs to organize hackathons. Hackathons is, well, as in the title of it's to inspire. But it's very practical. Let's say it's also for generating ideas that can be transferred and converted in innovation projects, which is where it in the end should take place. And what a lot of people forget, but for us it's crucial function of hackathons. It is spotting talents. It's connecting people, finding new people, expanding the local network with people that you never thought about that they could contribute to your challenges. So I want to congratulate Agrihubs with this, with organizing this very inspiring event. With I noticed that you have been working on very inspiring challenges, challenges that are related to, well, I call it IoT, with sensors and connectivity and so on, with the spatial dimension. I think it's well developed also in rural development. And well, as an extra point, we are also working for Africa, which is in the end also very important for the digital innovation hubs to make the knowledge, experience, tools, solutions, to make them also available for the countries that don't have the capacity to build it on themselves. So that's an extra point, and as some of you might know, we are exploring this part also from the project. Some final words. The Smart Agrihubs is a 4-year project, and we are now in the last year. So our main concern and our main activities are now targeting on how to make it sustainable, how to keep on working together after the project lifetime. So we have to sustain the network, so all the people that are involved, and there are literally thousands of people connected to this Smart Agrihubs network, but also the tools, how to sustain them. For the tools, we are working on sustaining and finding a business model for the innovation portal that contains all the knowledge that we have available. It's free of use, so please use it. You can go there, it's free. You don't only have to register, and then you can pick your cherries that you want. And another challenge is, of course, how to sustain the network. And for that, I think it's important to also to mention here that we are looking for ways how to connect the agricultural digital innovation hubs with the EDIHs. There's a network coming up. At the moment, the Commission is selecting and granting a couple of hundreds of those EDIHs that are not specifically for one sector, but for, let's say, more a country or a part of the country, a region. So how to connect our agricultural digital innovation hubs with the EDIHs is quite a challenge, because that's where we see the Commission is targeting on to make it more sustainable. So that's where we are now, and I want to thank the organization for giving me the opportunity, and I wish you a very nice and at most an inspiring event, and have fun. Okay, bye. Thank you.
Thank you very much, George, for your warm words. Yeah, it's a pleasure for us to have you here. So thank you again. And now let me go back to my presentation. Can you see it? Excellent. Thank you. George already talked about that, but we had in this hackathon, we defined 16 challenges to support digital innovation hubs for Czechia and Slovakia. Here they are. And in this hackathon, we have the honor to have 6 members of the jury, who is Emilia Oreščanin, Bente Liaby, Siak Wolfert, Jesus Maria Estrada Villegas, John O'Flaherty, and Janek Wagner. And now I am giving floor to jury to introduce themselves. Unfortunately, I can see only Bente here. Bente, hello,
hi.
Can you?
Hi, yeah, hi, Hanka, can you hear me?
Yes, I can hear you.
Yeah, thank you very much for inviting me to yet another Inspire Hackathon, and this time in the role as a jury member. So I run a small company called BLB. It's a research and consultancy around Earth observations and various applications, including for the agriculture sector, but not only, also ocean related. And I can see that from all the challenges here, that, and what you said, George, about digital innovation, I think this is cross-disciplinary, and we are building in Destination Earth, which is a huge effort by the European Commission. There are building, and we are moving towards digital twins, and innovation related to these twins, including here in the agriculture sector, is of course very interesting to see. There are many similarities and also special applications in regions. And I was very happy to see that this time, this particular hackathon was directed towards 2 countries. And I think when you niche down, you will find that you will find solutions that has more general value. So it was really a pleasure to read through this excellent reports and videos. Thank you.
Thank you very much, Bente, for being part of this Inspire Hackathon jury. And thank you for your introduction. Then I can see Jesus here. Jesus, can you show up and introduce yourself?
Hello, can you hear me?
Yes, we can hear you.
Yes, hello, this is Jesus Estrada. Just to introduce myself, I'm responsible for European funded projects in the Traxa group. That is a public company, part of the Spanish administration, especially focused on areas as biodiversity, agricultural information. One of our main customers are, for example, the Spanish Ministry of Agriculture and Biodiversity. And I have been involved in this kind of project for more than 8 years. And previously, I have been always, my activities have been always related to IT areas, for example, a security auditor or software developer. And also I have been a place for the evaluation of all the proposal. And I would like to say that I would like to highlight the high quality of the proposal. Thank you very much.
Thank you so much, Jesus. Thank you. And the introduction of the rest is up to me. So another jury member is Emilia Oreščanin, who is actually a colleague, a project colleague of George Beers. She is working for Smart Agrihubs and she works for Biosense Institute as a project manager assistant. Her field of interest are mainly connected to sustainable agriculture and circular economy with an end goal of leaving a positive impact of the agri-food industry. So this is Emilia. Another one is Siak Wolfert, who is a senior scientist and team ambassador on digital innovation for sustainable food systems at Wageningen Economic Research. Then it's John O'Flaherty, who is a technical director of Ireland's National Microelectronics Applications Centre. John is experienced in managing, commercializing, and evaluating the potential of innovative applications with a particular focus on delivering green IoT distributed system solutions. And the last one is Janek Wagner, who is from the Ministry of Labor and Social Affairs in the Czech Republic. He is a journalist, consultant, focusing mainly on new technologies and trends with focus on internet and all related technologies and activities. He has also extensive experience in media, education, and e-learning. So this was a short introduction of our jury members. So thank you again. And what exactly was the role of our jury? Our jury members were asked to read all 16 final reports and listen to the video recordings and evaluate the results based on predefined criteria. The criteria were the sufficient and effective report. The report should clearly respond to the challenge goals. Then it's the evidence of use of open data, Inspire, Geo, OGC standards, cross-sectoral interoperability, and cross-boundary interoperability. Then it's the innovation potential, market potential, outreach, and capacity development and sustainability. So there was a question if there is any coordination with other organizations outside agencies or the actual community and so on. And what is also very important is that you can also be a part of the jury. Just go to planforall.eu, check all videos, and vote for your favorite ones. Sharka will put the link to the chat. Thank you very much, Sharka. And before we announce the third place, I would like to remind you that we have a chat available for your questions, or you can raise your hand in the case of any questions. So that's all from my side for the moment, and we can finally see the results. So we are really excited. What is the third place? Where goes the third place, Bente?
Yes, so thank you for giving me the honors to present the top three of this excellent set of answers to the challenges. First of all, I would say that, this is, since the very beginning, I've been a part of the Inspire Hackathon movement, I would say, since 2016. And what is clear is that this is fun. We are doing this for fun, and every contribution is highly appreciated. Just to say that, and as I think Jesus, you said it, very high quality of all the reports, all the contributions here. And to not let the suspense be too rough on you, the third place goes to a challenge that addressed both the community and technology very explicitly. And that is number 13, Agro-environmental services. Congratulations.
Congratulations. Do we have anyone from the team of the challenge number 13?
Thank you so much. It's a pleasure for me and also for my colleague Martin. And we would like to thank to all, and we are very happy. Thank you.
Yeah, definitely. Also from my side, we really do appreciate this evaluation and also the process itself, because it helped us to gain a lot of new experience, new contacts. And it's great to see actually that we were able to establish close communication also across the border. So once again, also thanks to all those who help us to bring it where it is now.
Excellent. I will read some of the comments we were asked to comment on the winnings. And we can say that it was a clear and systematic understanding of stakeholders, which is very important in innovation, and the user requirements. And since this is an Inspire hackathon, so George, I think, yes, we want to inspire, but this is actually playing on the Inspire directive. So we are all about sharing and making data interoperable and solutions interoperable, just like the Inspire directive, now called infrastructure. So what was very good in this number 13 was that you were so conscious and explicit about mentioning standards and the Inspire, including the Inspire directive, which is one of the things that we want to continue to promote. And what more? I think I saw some.
I can see the comment from Emilia
yes.
that the execution of the idea was on high level. The future improvements are explained in detail. Both and the community aspects are highly important, which was recognized by the team.
Yes.
13.
Yes. Excellent.
So,
congratulations.
Great work. Thank you very much. And now let's have a look at the results of this challenge. So just a moment, please. And please confirm that you can hear the sound of the video.
Ladies and gentlemen, with this contribution, we would like to present the outcomes of this challenge, aiming to support the Agrihub establishment and provision of agro-environmental related services. We will guide you together with Mrs. Marcela Binzarova-Gergelova. Before the Agrihub Czechoslovakia project has started, there was no any GeoICT platform available in Slovakia. And now when the project is about to be accomplished with its mission, this challenge would like to demonstrate how project helped to improve the situation and what might be the opportunities to sustain the platform and enlarge the community. With that, this challenge wants to provide the answers for these following core questions. Why did such platform and community is important? How this platform might stimulate the community building process, and actually what shall be the main outcomes and products. It's very important that it's necessary to identify for whom such platform shall serve and what shall be the main stakeholders communities. And these, which you can see on this slide, were identified as those most relevant. Of course, this list is initial list and might be the subject of the future updates. It's also important to properly identify requirements of those stakeholders to make sure that this real demand for services and project is properly addressed. And with that, we have identified two types of requirements. First group goes towards the technology requirements, where we understood that it's important to make sure that users will be able to search, access geodata and map compositions. They would like to upload and download geodata, make sure that they are able to create composition of those geodata via map compositions and to be able to share these results or maps to the world outside. And the second type of requirements goes towards the community, where the users of the platform shall be able to register, actually search and use the information made available, but also provide and contribute with their information and the knowledge they have available via publishing of the articles and news. Data represents the important base for any GeoICT platform and community behind. And we have tried to identify the most relevant data resources from the global to local scale. And with that, Copernicus definitely represents one of the core pillars for serving data of high importance for agri-food sector. And with that, also for the Slovakia area, there was established Slovak Copernicus webpage, where users can already access, and towards the future, will be able to access selected data for the country region. Second important data source comes from the Inspire, where really interesting data resources starts to be made available, which are already harmonized, and with that contributing to cross-border interoperability. Last but not least are also any other, we used to call them as is data, which we were also able to identify, and they shall be able to improve the quality and availability of such resources, making this list kept regularly updated. And it's very important also to be aware that if we want to make sure that these data are actually properly transferred from producers to the users, technology provides important functionality and infrastructure essential environment. And this challenge has explored how the Hub for Everybody platform can be used. What we found out using this platform is that this platform has proved to provide very useful and easy connection from desktop to WebKit's geodata transfer and share with strong support from developers. But what is also important to mention that considering the maturation of the technology, it's important to support further development with testing and strengthen the underlying infrastructure. And now I would move the word to Marcelka, and she will guide you through the rest of the contribution of our challenge.
Thank you, Martin. I will share my screen. Thank you again. Next part of my presentation will link to use cases because several of them were addressed in this challenge. The aim of challenge team was to prepare datasets to meet the requirements of farms. The Ziffer farm was chosen for this purpose. The use case feeder through processing levels. The first was data collected for Ziffer farm, and second, processed the data that were created for Ziffer farm within this challenge. The dataset produced for Ziffer farm are stored in a single location and are available via a desktop browser and web platform. The second level was linked with data processing for the target farm using the EO-Browser platform. The use case transferred the approach to the academical environment. The use case also had two processing levels. The first of these concerned education, knowledge base, transfer, and training program itself, in which students work on the data collection of the most important datasets for farmers. The first stage, data were collected for three farms which are listed in this slide. And the second processing stage, we examined the data collection process for data processed for 25 farms. This part of processing also include the creation of reports for selected datasets on selected base map, and also present outputs and outcomes of students' work in a desktop browser, QGIS, and web platform, Agrihub platform. This use case examined the topic of agriculture subsidy support in Slovakia. The activity was intended to increase the awareness of end users when applying for subsidies. Many farmers face serious problems with applying for subsidies. The European project in Slovakia is also participating, aimed to improve and streamline the application process for farmers. And the last use case devotes the topic of predict analytics in agriculture. The challenge applied an innovative experiment approach and involved PhD students. We want to mention these students because it solved an important issue, design and application of the prediction model for crop yield estimation of selected agro-commodities for strategic supply chain management using big data and machine learning. Two models, as you can see, were tested, and our challenge contribute on this use case by providing data. The use case is currently in a finalized phase, and when the data from this use case are or is available, it will be shared via the Agrihub platform. Our intention involved two steps: to develop platform and build a community. It is interest of all challenges to work together to ensure the future sustainability for the Agrihub platform. And as we reach the end of our presentation, we would like to thank the all participant in this challenge for their hard work and commitment, and really it was a pleasure to work with all of you. Thank you so much, and see you in the next hackathon.
So these were the results of challenge number 13. Once again, congratulations to all of you. And now we are going to announce the second place. Bente, can you tell us where the second place goes?
Yes, I can. First, I would like to remind all of us that in this hackathon, we were addressing both data, use of data, analytics, some IoT, so sensors, and also building tools for software tools. And in this case, the second place goes to a challenge that created a new tool for a platform for everybody to use, to several of the other challenges to use also. And the second place goes to Field Calc number 11. Congratulations.
Congratulations. Anyone from the challenge number 11? I think I can see Herman here.
Hello.
Hi,
Yeah.
Herman.
Thank you for this prize. We are also really excited about the tool we have created, and we are determined not to throw the results or this tool away after the hackathon, and we want to make a viable product from this tool, and we hope we will see it as some part of business or in the market in the future. So thank you.
Crossing fingers, Herman. Thank you very much. And now we will see those results.
Ladies and gentlemen, good morning. My name is Herman Cznewajs, and it's my honor to present you outputs of challenge number 11, automatization of calculation of management zones based on yield potential. I will show you the content of the video. Firstly, we will say what was the motivation or what was the problem we were trying to solve. Then what is our vision or our solution for that problem. And then we will go through solutions step by step. We will find the input data, and then I will show you how our output tool works. So what was the real challenge for us? The main challenge are the fertilizer prices. It is not only current topic, it is long term, and it is clear that the trend will trend to decrease the fertilizer use will continue in the future. Also, the European Green Deal is planned for many decades, and one of its part also wants less fertilizers to be used. All national and EU subsidies also support ecological farming and environment-friendly approach. So it is clear that we shall use fertilizers as efficient as possible. I also heard about some farmers that due to the fertilizer price increase, do not use fertilizers on conventional fields, but it leads to significantly low yields. So what the challenge was to answer on question what shall we do with the fertilizers, or how shall we use them? We see the future in individual zone approach. It is opposite to uniform rate application, and it's based on the fact that the field is usually not uniformed, but there are some zones which needs more fertilizer because there is more vegetation, and then some zones where there is lower potential for crop growth, so not so many fertilizers has to be used there. And unfortunately, uniform fertilizer rate is traditionally applied, even when it doesn't help in some parts in the field and there is too much fertilizer, which then goes into rivers and lakes. And so we said, let's try to do it in a clever way and apply the fertilizers in those places where it helps and saves some money, and where the crop doesn't need it, we don't have to put much fertilizer. I love that this solution is both economically meaningful and environment friendly. So the main thing we have to do is to find the variability in the field which corresponds with the need of fertilizers. So as we said, one input should be some data which will show us some heterogeneity in the field. And we think satellite data offer us exactly what we need. The data are free, there is good spatial resolution, and there is sufficient revisit time, and the images from satellites are large, so we usually process one image, and there are all fields of the farm. There are more alternatives which images to use. We in this challenge used ESA's Sentinel satellites, which are the most advanced, but there are also satellites from NASA, which are also fine. Then we need to analyze the images to get the right information. We calculate so-called vegetation indices, which tell us how much vegetation is on any place in the farm. And when we focus on one field, we see that there is heterogeneity in the field, that not all the areas in the field are of the same values. There are some fields where there is more vegetation and some fields where there is less. It can be of various reasons. For example, some mice eat the seeds, and it tells us that there is no need to put the fertilizer in those places, or the agronomist should know the reason, and he can just decide what strategy he will apply. Yeah, there are dozens of vegetation indices. There are moisture indices as well, and some are more general, some are more specific, used in a certain situation. And to understand the indices and to help the farmers and the researchers use them and understand them, we created a web page about them. It is a part of Hub for Everybody, and Hub for Everybody was created in Agrihub Hackathon as challenge number 6. So that was mutually beneficial cooperation. We can try to see how does the page look like. Yeah, there is some explanation what does the index is about, how is it calculated, and in some satellite systems there are some references to literature, and there is also example how does the index look on farm. So that's it. There are few indices, but more will be added soon. And now we are getting to the second input, and it is field borders. There are again more possibilities how to get them. The best and easiest way is when the farm has its own database of the fields and crops. However, it is not very usual. Most of the farmers don't have them. And so that the second option is the national database of land parcels. This database is open and it is up to date. However, in this database, often more fields with different crops are merged to one land parcel, and it makes correct in-field analysis impossible. because we have to have borders of every crop, not to mix more crops in one field. And yeah, our idea is to improve the public border database by classification of satellite data. From satellite time series, the algorithm is able to distinguish crops and then create border between them. So the process is not fully automated yet, but we tried this process could work. We see in this picture the unsupervised classification. Then the classification was vectorized, and here is a comparison of this layer and data from the farmer. So we see, or it is, yeah, we see the most of the lines corresponds. And when we have borders and input data, we are ready to do the calculations. A Python script was created to divide the fields into the zones. And also some basic interface was developed during the hackathon to enable testing the tool. Although the tool is still in some prototype version, it is public and anyone can try it out. This should be the outcome. There is a field and it is divided in zones which tell the farmer which places are better than the another, and the farmer can decide where he will put more fertilizer, right, and where less. And we can also give it a try. I hope everything will work, so we can switch to English, and we have to zoom in, and now we have to wait a few moments because the database is loading. Now we can just select fields. We want one or more fields. We want to calculate the zones. So, for example, those three. We say how many zones we want to on the output, how it should be smoothed, and then which index. Then we get dates, and then we can find which day we want to calculate, or from which day the satellite image is from. And then we just get the zones and we'll see. Yeah, and we see the result. And it says which areas are better than the another. We also might want to change the output zones number or amount. And yeah, now we have 5 classes. And now farmer can arrange the variable rate. The next step is to download the data and put it into machine. And well, this application is for testing, so there is no download option, but it was integrated as a part of challenge 1. It was integrated to a farmer's application, farming site, and there is possibility to download the zones, and then a farmer can put it into the machine. And yeah, the great thing about this tool is that we can have just a current image. This image is few days old, so it is perfect that we can have really up-to-date data. And that's all from me. Thank you for listening me. Thank to all the participants of the hackathon, and especially thanks to our amazing team for the great job we have done together.
So these were the results of the challenge number 11, and I would like to point out a very huge collaboration with other challenges when it comes to this challenge. Herman mentioned several challenges that were cooperating with the challenge number 11s, and for that I would like to say a big thank. And now the moment of the highest tension is here. Bente, tell us who is the winner.
So, as for the others, I would like to point out some feature of the Inspire Hackathon. One of the feature is that we want to create a space for continued collaboration between the different hackathons. So continuation has been important for us. Also, we also want to have different types of hacks, so also on ideas. And the winner is an example of a challenge that started with an idea that has gradually over several hackathons developed into something very much more concrete. And as you said, Hanka, collaboration across the different challenges is also something that we have encouraged in the Inspire Hackathon. And this is also an example of that. So the winner is number 9. A new social space for geographic information. Yes, congratulations.
Do we have anyone from the challenge number 9?
Well, I think that would be me. Hello. So hello, and first of all, I would like to thank you to all my colleagues, because it was a collective effort. And I have provided the technical support, but the real value of our solution is really in the interesting content and research topics. And that is something I hope more of you will help us with, because we have successfully started the web space, as Bente said, but it is now up to all of us to give it life and publish real data with some value for the community. The data and information that can help with the development of specific regions, for example, to help promote those regions. And that is actually the main goal of the research of Ota Cherba, who deals with the attractivity of regions. Then with Wensan, for example, we are working on explanatory web pages about agriculture, or to be more specific about vegetation indices. Herman has been talking about it a minute ago. And those pages should be really useful for anyone who is dealing with precision farming and is not really an expert on the topic. And well, that's it. I hope more useful content will come, because this hackathon was just a start for us and for everybody. And of course, I have to thank Marketa to keep us all
on the right track, and especially Karol Charva to give us the right direction. So thank you once again.
Thank you, Franta, for your words. And now let's see those excellent results.
Hello everyone, this is a short introduction to our Agrihub Inspire Hackathon Challenge number 9 called New Social Space for Geographic Information, Sharing and Education. In this challenge, we wanted to introduce and spread the usage of Hub for Everybody portal that enables everyone to develop, publish and share their own maps, learn how to build map compositions, build own maps describing specific places or local problems. And all these tasks were supposed to lead to support effective reuse of existing data or build new data content, promote regions, or prepare new type of educational content. I think I can confirm that our tasks were successfully fulfilled. We were able to work on 3 specific use cases that will be later presented here, and that were focused specifically on the tasks mentioned earlier. But first, let me briefly tell you something about the background of the number 9 challenge. This challenge has been led by 3 mentors, Mr. Otakar Čerba, who was mainly responsible for one of the use cases, Mr. František Zadražil, who is the main developer of the technology, and then myself, Markéta Kolárová, responsible for smooth communication within the team and participants. As I already mentioned, our team has been working on 3 specific use cases closely linked to the ambition of the challenge. First, we decided to go and further develop the regional attractiveness challenge, where we have used the data collected in a certain region and thus developed and uploaded a new map into the Hub for Everybody portal. Second was the use of vegetation indices on Rostenice farm, whose results will be presented by Vincent with reused data from the past. And the last but not least ambition of the challenge, creating of an educational content, was covered by our practical workshop organized for the students of Charles University in Prague. All of this would not be possible to organize without the main portal Hub for Everybody, which was developed by František, who will also brief you about the technology that stays behind of this work. So, we were able to organize a couple of overall meetings and 1 large webinar dedicated to Hub for Everybody technology, with an audience of registered 120 participants, geographically covering countries throughout the whole Europe, then Africa, South America, and also Asia. And as I already mentioned, we have organized a separate practical workshop for students of applied geoinformatics and cartography at the Charles University in Prague. In our team, besides of the core team around the Plan for All organization, there were 7 registered participants from Uganda, Nigeria, Burundi, India, Pakistan, Uzbekistan, and Slovakia. So those were the overall information about the challenge, and now let's move on to the specific parts and results of our challenge. Thank you.
Hello, my task here is to tell you some technical details about the Innovation Hub, which is a cornerstone for our challenge. My name is František Zadražil and I welcome you to this part of the presentation. From some points of view, the portal can be viewed as a common web portal which contains some blog section. You can open it here, which contains forums and articles. But our hubs are maps oriented, which means that the core of the portal lies in geodata and maps. And this functionality is hidden in the tools that are not visible to the user. We call this the geodata management workflow, And to say it in short, it is a set of tools integrated together into one complex solution, which is designed for anyone to be able to not only browse through existing maps, but most importantly to publish own map layers and maps and then share them with others. There are components for publishing data on the server. That service is called Layman here. There is a framework for web map applications, HS layers. There is a desktop tool in the form of QGIS Layman plugin. And of course, if we are dealing with geodata, there must be a metadata catalog, which is called MITSCAF in our case. All those tools give the user a simple way to publish data, to create thematic maps, to make them available on a web map or through the QGIS desktop. And recently we have adopted a new component into our hub, and that is QField. QField is a native mobile app based on the same libraries as QGIS itself. It is designed to work with maps out in the field and to collect data. Close integration of QField into the hub is actually covered by another challenge, and that's challenge number 10. So if you are interested, please check this one too. And if we are talking about a web portal, I cannot forget to mention the content management system.
Hello, my name is Vincent. I represent you.
The components and create the actual content that is visible to the user. The content management system is based on the Wagtail CMS, and we have extended the default functionalities with the ones that are needed for working with geodata. So there is, for example, a map widget which allows you to insert a full-featured HS layers map into any web page you are creating using the standard content management tools. So you can create a page, you can insert some HTML to the page, you can insert some text formatted, you can insert images, and in the very same manner you can insert interactive maps. So this whole package of tools lets you quickly create maps and nice web presentations including those maps. You can present your research result this way, your students' works, or just your private data that you want to share with someone else. You can create story maps or whatever allows your imagination here. Okay, that is all from my side in the context of the technical solution of the web portal. Thank you for your attention.
Hello everybody, I would like to introduce the territorial attractiveness maps which our group is publishing and sharing through the hub for everybody. What is territorial attractiveness? It is an assessment of regional potential. You can see 3 levels of the territorial attractiveness: the national level, regional level, and the local level, which is the actual topic of our group. The main difference between national or regional level and the local level is the input data, because for the national level attractiveness we are processing usually the statistical data, but we do not have such type of data for the cities or municipalities. Therefore, we have to use 3 other types of data. First, points of interest. The second, land use land cover data. And third, some local data such as surveys or data collected by municipalities. On the local level, we cannot work with the administrative borders. Therefore, we use regular grid, 100-meter hexagons. As I mentioned, we publish this data on the hub. In this slide, you can see two approaches for attractiveness assessment of the Klatovy, and we use slider to enable to see both types of attractiveness. If you want to know more about the local attractiveness and visualization of local attractiveness data in the hub of everybody, for everybody, sorry, you can visit the blog of Hub for Everybody, and there is a short article, short blog post about local attractiveness with some map examples. Thank you very much.
The Spectral Indices page made on Hub for Everybody with Wagtail and QGIS. So this page lists several spectral indices used to monitor agriculture. Let's begin with the Normalized Difference Tillage Index. First, we have the definition of it. It quantifies the agricultural preparation of soil by measuring the difference between two shortwave infrared satellite bands. How do you calculate it? You have the general formula here, and the bands are according to Sentinel-2 satellites. We have the link of the reference. It's easy to add it with Wagtail. And an example of NDTI on Rostenice farm, July 1st, 2020. So we can easily which parcel have more soil preparation. Let's go to another index, the Normalized Difference Vegetation Index. So it quantifies vegetation by measuring the difference between near infrared, which vegetation strongly reflects, and red light, which vegetation absorbs. For example, when you have negative values, it's likely that it's water. On the other hand, if you have an NDVI value close to +1, there's a high possibility that it's then green leaves. There's a general formula here. Once again, the references. And an example on Rostenice farm of application. Here, so you can see you have greener parcels than others, so different density of vegetation. Let's go to another index, the Enhanced Vegetation Index, EVI. EVI is for crop with higher canopy density, and EVI tends to saturate. EVI is more important to use for this type of crops or growing stages. It's like an advanced version of the NDVI. How do you calculate it? You have the general formula here, once again, references. And on the map, I will show you something you can do. You can see here my layers. I have the Rostenice borders of the parcel. I have a layer for May and a layer for April. So we are viewing the layer for April. You can here put the language into English. You can here enable the swipe. And the swipe allows you to compare two layers. So we have the May layer on the right and the April layer on the left. We can see it's getting greener on May. So it's really useful to take decisions. It can help to take decisions to monitor agriculture. Let's go to another index, the Radar Vegetation Index. Every eye can be used to monitor the level of vegetation growth. The SAR can penetrate the clouds, thus it has the potential to monitor the crop growth in all the seasons. It ranges between 0 and 1, and it is sensitive to the biomass. How do you calculate every eye for S1? So the general formula for every eye is here, and you have to know that for every eye for Sentinel-1, the calculation we call a custom script you can find on the reference if you want to know more about this. So we have a layer for April, a layer for May. If I zoom on the farm, the location is not set on the map already, but it can be fixed. And so once again, we can enable the swiper. If I put April on the left, May on the right, I can compare easily the two layers for this with this index. And we can see we have more greener parcels on May, so we can say that vegetation growth, we have some change in the vegetation growth. So this is the end of the presentation. I hope you enjoy it and have a nice day.
Okay, so I hope you enjoyed the results of the winning team of the challenge number 9, and I would like also congratulate to all challenges, all teams who did an excellent job, and jury had a very hard work with choosing the top 3. Now, I would like to give a floor to our godfather of the Inspire Hackathons, Karel Charvat, to say a couple of words about this hackathon. So, Karel,
okay,
the floor is yours.
Thank you, Marketa. Thank you, Bente, for introduction of the winners. At the beginning, I would like to congratulate to all winners, but I would like also to congratulate to all participants, all challenges, also who was not winning, because I think that all done a good job. And as you saw, also on the 3 winners, yes, it was not only about competing, but it was also about collaboration. And I would like to recommend you to go through all other solution, and you can see that more and more challenges cooperate together and try to use the experiences from one challenge to other. And I think, as already Bente mentioned, about this is Inspire Hackathon. Yes, we were with Bente on the first hackathon. It was in Barcelona, 2016. And during this time, we collect a number of experiences. We run this hackathon not only in Europe, but also in Africa and in South America. So we are trying to use these experiences worldwide. And I am telling every time that Inspire Hackathon is not event, it is process, yes? Because when we start with this process, we saw that very often after end of the project, end of some activity, result disappear. And the goal of Inspire Hackathon is to guarantee continuity. On the end, let me to thanks, of course, to all people who helped to organize this event, mainly Hannah, Sharka, then to all members of jury, of course, one more time to all people who participate on this big game. And I would like also to thanks to Smart Agrihub's project, because this project helps us not only to organize this event, but also for some challenges, help to discuss already the ideas and how to turn these ideas into the business, yes, because this is also important. And I hope that we found there some inspiration from the result, that there is big chance to move the things to the business, to use the solution in other future research projects. So transfer the knowledge from could be agriculture to maritime or to the tourism. This is the goal, and I hope that on the autumn we will have chance again to meet and to work together. So one more time, congratulate to winners, thanks to all, and see you next time.
Thank you, Karel. And yes, see you in the next hackathon.
Yes,
one more remark on the end. Yes, all from you can become now also the member of jury, because we open also public voting for the best application. So you can go all to Plan for All web pages, see not only videos, but there are also very nice reports which explaining the solution. So my recommendation is to look on all this report, because I think that it could be also good inspiration for anybody what could be done with all the technology and what could come in the future. So see you.
See you.
See you, and thank you for being part of this Inspire Hackathon.
A pleasure being here. Bye-bye.
Bye-bye.
Thank you, bye.